Question 5 comes in two parts. The first part asks us to again solve this differential equation. And because we're given some initial conditions that when x equals to 2, y equals to 0, that means that we're going to need to find a particular solution. Now, if we look at this differential equation, we see that it's neither of the two previous kinds that we've talked about. It is not one that we can solve by direct integration, like we did for question 4, nor is it one that we can solve by separating out the variables, like we did for questions 1, 2, and 3. Instead, this is our third type of differential equation, the one that we need to solve by making a substitution. So what are we going to substitute? Well, the point of making a substitution is to eliminate one of the variables and turn it into something that we can easily differentiate. And usually the variable we want to eliminate is going to be the y variable. So let's see what we can do. Well, to eliminate the y variable, there are actually two y's in this differential equation. One of them is here, the plus y at the end, but the other one is inside this dy dx. So we need to know not only what y equals, but we need to find out what is dy by dx. But that's not too hard, because we know that y equals to v times x. So what is dy dx? I have to differentiate this expression with respect to x. One thing to be careful of, however, is that this v is not a constant. It is instead a function of x, so we need to differentiate that as well. So we now have a product of two functions of x, which means I need to use the product rule to differentiate this expression. That means I get what? Differentiate the first part, hold the second constant. I get dv by dx is times x, plus hold the second part, differentiate the second part, hold the first part constant, v times 1. So this is my expression for what dy dx is equal to. Now I've got an expression for dy dx and an expression for y. I can substitute both of these into my original equation and remove y from the picture. That is, I am going to get x times, what do I replace it with? dv dx times x plus v is equal to 3x plus vx, replacing y and dy by dx. So that means if I look at this, I can see that I actually have I have x's in all of my expressions, so I can cancel these out as such. Now from there, what do? I now have dv by dx times x plus v is equal to 3 plus v. But again, if we look at this expression, we see we've got a v at the end, so I'm going to cancel those out. That leaves me with dv by dx times x is equal to 3, or dv by dx equals to 3 divided by x. So this one is one that I can integrate just by using direct integration. I can solve rather by using direct integration. And I get v is equal to the integral of 3 over x dx. So v is equal to ln modulus x plus our constant of integration. However, we are not given this initial equation in terms of v and x, but rather in terms of y and x. So we have to go and substitute back in for v to get y divided by x is equal to 3 ln mod x plus a constant, or in other words, y is equal to 3x ln mod x plus c times x. So this is the expression that we're going to use when we're trying to find our particular solution. How do we do that? Well, we know y equals to 3x ln mod x plus cx, and we know when x equals to 2, y equals to 0. So we substitute, that's a very funny 0. So we substitute these values into our expression, our equation, and we get 0 is equal to 3 times 2 ln 2 plus c times 2. And if we rearrange and simplify this, this means that c is equal to negative 3 ln 2. So what does that tell us about y? It means that y is equal to 3x ln modulus x minus 3x ln 2. And again, we can combine these into one fraction. We get y is equal to 3x, factorizing out the 3x. Then ln x minus ln 2 is going to be ln modulus x upon 2. And this is the final answer for y. It is not the end of question 5, however, because question 5 has a second part. The second part asks us to prove that in general, d squared y by dx squared is equal to 3 over x. Well, if you recall, we start with this equation. X by dy dx is equal to 3x plus y. So what are we going to do? We're going to differentiate both sides of this equation. The left-hand side, we need to use the product rule to differentiate. So what am I going to do? I'm going to differentiate the x, hold the dy dx constant. So that gives me 1 times dy by dx plus hold the x constant and differentiate dy by dx. This will give me x times the derivative of the first derivative is the second derivative. So d squared y dx squared. The right hand side, if I differentiate 3x, I'm just going to get 3, and if I differentiate y, I'm going to get dy by dx. Now, if I look at this expression, I see that I actually have a dy dx on either side, a positive dy dx on both sides, so I cancel them out. This means that x times my second derivative is going to be a constant 3, so d squared y by dx squared is equal to 3 over x in general. And thus we have shown what we wanted to, QED.